Hi, this is M.Poornima, and you're watching video lecture series on protection switchgear. Today, in this series, we are going to discuss about circuit breakers. Come, let's go into the first. We know that this is the basic transmission and distribution stations. Here we have first power bank, and when the power is produced, it is given to the step-up transformer. Step-up transformer, the voltage or current are step-up, and it transmitted with the high voltage transmission line, and then again it comes with the transmission substations, and on that substation we are again transmitting the power and to the another substations, and with the help of the transformers, home transformers, we are supplying the power to the residentials. This is the basic power system structures, and here we are going to discuss about what is an arc. So first thing, what is an arc? Arc is defined as, because here we can see what is an arc. So arc is defined as uh, during operating of a current carrying contacts. So when two contacts, here maybe whatever two contacts which carries a current in a circuit breakers, the medium in between opening contact become highly ionizations through which the interrupted current gets low resistive path and continues to flow through this path. Even the contacts are physically separated. If we have two contacts, when these two contacts are moves, what happens? With these two contacts are current carrying contacts. When the two contacts are moves, what happens? Here in the space which is having less resistive path, which the current carrying conductors moves, then that time the what happens? It is the arc is produced. That is the definition of an arc. Here comes the during operating of a current carrying contacts. So current carrying characters become highly ionization through the interruption current gets low resistive path. So what happens? The low resistive path continues flows through this path. Even the contacts are physically separated. Both the contacts are physically separated. So this is the definition for arc. And here we can see the arc phenomena, how the arc is formations. Here we know that this is a moving contact, this is a moving contact, this is a fixed contact. So when this moving contact gets moved, what happens? Here the arc is produced. We know this contact this contact, the current is flows, the flow of current, electrons is there. So when suddenly this moving contact moves, what happens? Here comes that arc is produced. Here comes the arc is produced. Because why the arc is produced is the path, resistive path is very low. Here we can see this image here. With this we have a fixed contact, and with this a moving contact. This fixed and moving contact placed in between the closed tank. This fixed and moving contact is placed inside the moving closed tank. The tank may be filled with gas or oil or whatever may be. So what happens? Why the gas or whatever the property it is? So it is used to reduce the arc. It is used to reduce the arc formation. So here we can see this moving, when the moving contactor moves this side, what happens? The arc is produced. The arc, that is gas formation, arc is produced. Here we have an air, we have an space air, we have an oil, etc. This is the basic of arc formation. Okay, now coming to this is the basic structure of circuit breaker. Here we have an stationary contact. Here we have an stationary. This is what stationary contact. This is a moving contact. This is stationary. This is a moving contact. Here the arc is produced. This was switch. MCB switch on and off. Here we have a catch. We have a catch, and here we have an electromagnet which pull backs to its original position. Here we have terminals. This is what what are the paths inside the circuit breakers. These are circuit breakers. Now, in this topic, we are going to study about circuit breakers, what are circuit breakers and type of circuit breakers, and arc phenomenon, and principles of arc extensions, method of arc extensions, and what are the important terms we used in this circuit breakers. Okay, come, we can go on the video. First thing is circuit breaker. So first we can see what is circuit breaker. A circuit breaker is a piece of equipment. We know that there's a part of an equipment which can make or break, which can make or which can break a circuit either manually or by remote control under normal conditions. It can be made by an or normal condition and or by any control methods. So break the circuit automatically under fault conditions. When the fault occurs, what happens? It breaks. That breaks the entire circuit. It isolates the circuit in any fault conditions. Okay, this is what important thing. Next one is make a circuit either manually or by remote control under fault conditions. So it will make. So break will be automated and make may be manually or automated. So both by remote control or manually, whatever may be. So remote control is a controlling from somewhere. So this is what a basic of circuit breaker. Now coming to operating principle of circuit breaker. What is an operating principle? A circuit breaker essentially consists of fixed and moving contact. We know that it consists of one fixed contactor and one moving contactor. Fixed contactor and one moving contactors called electrodes. This is called as an electrodes. This is called as an electrodes. Yeah. Now, what happens it is under normal operating conditions, under normal operating conditions, we have a fixed contactors and we have a moving contactors. Under normal operating conditions, these remains closed and will not open automatically. So which remains closed, and it will not open automatically unless the system become any faulty. Until the system is in normal condition, this will not open. When the fault occurs on any part of the systems, the tripped coil to the circuit breaker gets energized. The tripped coil to the circuit breaker gets energized, and the moving contactors are pulled apart. Here what happens? The moving contactors are pulled apart from the fixed contactors by some mechanism. Does the opening the circuit breaker. What happens is when it's pulled, what happens? The circuit breaker gets open. The circuit breaker gets open and automatically arc is produced. Okay. Here, what is an operating principle? Here we have continued with the last slide. When the contactors of a circuit breakers are separated under fault conditions. Here we can see the contactors. Now where the contactors are separated. Now the contactors are separated. The arc is stuck between them. Here we can see the arc. Here we can see the arc. Arc is stuck between them. Here we can see the arc is stuck between them. The arc is produced. And then the production of an arc not only delay the current interruption, but also generate enormous heat. We know the arc produce enormous heat also. We know that heat. Arc is also produced heat energy, which may causes damage to the system. This is very important, which may causes damage to the system or to circuit breaker itself. Therefore, the main problem in the circuit breaker is to extinguish arc within the short possible time. We have to reduce this arc, extinguish this arc in a short period of time. We have to extinguish this heat with a short period of time so that the heat generated by it may not reach a dangerous value. This is the main operating principle of circuit breaker. We have to extinguish this arc in a short period of time to avoid the damage to the system or a circuit break. Okay, this is what operating principle. Here we can see the basic. This is the bus bar, and you know that this is the bus bar. Here, this is a circuit breaker. We have a current transformer. This is a load, and this is a trip to circuit breaker, triple circuit, and no contact of relay and relay coil. When some fault occurs in load side or some fault occurs in load side or system side, source, whatever may be. What happens here? It is this current transformer sends the current. Current transformer always sends the current. When the fault is occurred, when it is normal conditions, then nothing will happen. The current flows from system to load, whatever system to load. The current flows from system to load. When the fault occurs in the system or else in load, what happens? This current transformer sends the current, and this current transformer gives signal to the relay coil. This relay coil gets energized. When this relay coil get energized, what happens? This contactors contact with the circuit breaker. This relay contactors gets attached to the coil, circuit breaker coil. When it get attached to the coil, this get energized. This coil get energized. This trip to the trip coil of circuit breaker gets energized. When this coil get energized, what happen? This is attached with the circuit breaker. This is attached with the circuit breaker, and finally the system is isolated with between the system and the load. Finally, the system and the load is isolated with the help of circuit breaker. The system and load is isolated with the help of circuit breaker. This is the basic working of circuit breaker. Okay. So today we have seen what is circuit breaker and how it is working, etc. In next class, we can see the remaining topic. Thank you so much for watching. Thank you. Have a nice day.